Hi everyone. In this video I'm going to show an update to the program that I released about a month ago or so. Basically it's a program that makes it very easy to view telemetry from an Arduino or any microcontroller or FPGA, and it can also do data logging. So I'll start off with a couple really short demos. So I have my balancing robot right here, which is in a couple of my earlier videos. It isn't, the motors aren't powered on, but sensors are all up and running. And you can kind of see here that we have a lot of live data being charted. So we have the accelerometer readings up here, we have the gyro readings over here, we have the calculated pitch angle right here. We have that shown as a line graph, and then also as a histogram, which you can kind of see is what you'd expect, a nice Gaussian distribution. And then we have it kind of in like a dial or gauge type visualization, and it's auto-scaling like the line chart, so that's why it's kind of jumping around. If I just get that auto-scale up, then it'll pretty accurately, hopefully I can get this in frame, you can see that dial moving pretty accurately in response. And then down here at the bottom we have, so there is this transmitter that I made for the robot, and down here at the bottom we have the two gimbal measurements, and so if I move the gimbal up, down, left, right, you can kind of see it moving along. And then over here we have the three knobs, which are these. So if I try to get this in frame, we can turn the knobs and they all show there. And so you might be noticing that the measurements are pretty noisy, like right here. And that's because this is a really old design. I made this about 3 years ago when I didn't really know as much as I do now. And I didn't have nearly enough decoupling capacitors. So that's why if you look here, these are all raw ADC readings on the bottom. And you see we have, like, you know, plus and minus almost 7 or 10 counts of noise, which is horrible. But it's just because I didn't have enough decoupling capacitors. Anyway, and then my second demo is I have a little Arduino here, and I have a potentiometer, I have a light sensor, and then I have a thermistor. And let me show you that. Alright, so here we have the potentiometer is over here, the top graph. We have the light sensor in the middle and the thermistor down here at the bottom. And I just have sort of a time domain chart, and then I have dials, and then I have histograms. So we'll start with the potentiometer. If I turn the potentiometer, you can see it will respond accordingly. And now that it has auto-scaled the thing, you can see the dial looks reasonable instead of jumping around because of how auto-scaling works. And then we have the light sensor in the middle, and it's this little guy right here, a little cadmium sulfide cell. If I cover it up, you can kind of see it responding accordingly. If I aim it up towards the lights, it'll get even brighter. And then we have the thermistor, which is a little surface mount part that I have soldered into a header here. So if I touch it, you can see the temperature ramping up. And if I let go, you can see it ramp down. Okay, so what I'll do now is I'll explain some of the updates since the previous version, so that way if you've used the older version, you kind of know what to look for. After that, I'll kind of cover what I did in the previous video. I'll show you how to write the Arduino sketch, so you can have your Arduino talk to my software. It's really easy. It takes about 10 or 15 lines of code, not a big deal. After that, I'll go more in depth into how to use the program, so that way you can figure out, you know, how to draw the charts and what the options are and where you can put them. And then finally, I'll go over the source code and show you guys where everything is laid out. Oh, my camera just cut out. But so picking up where I was cut off, yeah, I'll go over the source code and show you guys how it's all laid out. And if you feel like learning Java and OpenGL, you can play around with the code and make it do whatever you want. It's free and open source. So for the brief demo of the new features, I'm going to go ahead and switch back to the balancing robot demo. Alright, so here we are back at the balancing robot demo, and the first rating is corrupt because it probably connected right in the middle of a line, but we'll see that go away in a second. There we go. And so the new features for people that have seen the first video. It's been all ported to OpenGL, which means it'll be quite a bit faster, especially for large data sets. And in order to do that, I had to rewrite pretty much all the charting stuff, so I'm no longer using JFreeChart. I wrote all of my own charts from scratch. So you can kind of see here we have the line chart up top, and I added the ability, so before if you wanted to remove charts you had to remove all of them. You had to click down here at reset, and I added the ability to just click on a little X icon up top. So a small feature, but you know it's helpful if you want to modify things. Another feature that I added, probably much more important, is before you can only watch live. Like right now we're seeing the live data come. But obviously, what if you want to look at the past? Like, you know, here we have an event that looks kind of weird. Well, now if you use the scroll wheel, you can rewind. So you can scroll forward and backwards. And then if you want to get back to the live view, just scroll all the way back down until you get to the end, and it'll switch back to live view automatically. And so here we have this weird event, and you might want to take a closer look at it. So what you can do is you can hold down Control, hold down Control while you scroll, and you can zoom in. So the zoom in, like the center of the zoom is at the end of the chart, so I'm going to go ahead and scroll that way. So you can kind of see here we can get a much closer look. You can scroll, I mean you can zoom in as far as you want to the individual samples, and then you can scroll back out. And then a feature that I'm not sure if you guys would benefit from as much, but one of the things that I really wanted to do is I'd want to leave this running live on a computer, and then I could be across the room working on something else, and I want to be able to glance over and kind of see you know, what's happening. And obviously if it's small like this, if you're across the room, you can't really see that. So I wanted to be able to adjust a scaling factor that would make the text bigger and the lines thicker, you know, basically scale everything up. And so if you hold down Shift while you scroll, you can do that. So you can kind of see it makes everything bigger. So the fonts are the most obvious change, but it also makes the lines thicker proportionally as well. And so you can make it ridiculously big. And as you can see here in the dial chart, I didn't really add much error checking as far as if things are overlapping, so it gets kind of ridiculous. But I'll have to work on that later. And so obviously, if you're going to be across the room, you might want to you can remove all charts by clicking Reset, and then just have one big chart. So let's do one for pitch, and AutoScale. That's showing the new stuff. So I'll rewind, and then yeah. So if you hold down Shift, you can make it, you know, really obvious. Like you can be across the room and you can see that. Anyway, not sure if you guys would find that as useful, but it's one thing that I really wanted to do. Let me restore the old layout. So we're back to the original layout that we saw earlier, and so there's a few other types of charts. Let me remove the pitch chart over here. And so there's the Fourier transform, which is a frequency domain type chart, and I guess we could look at anything really. Let's look at the accelerometer. And so it'll do a Fourier transform and give you the frequency domain. It assumes that the units of the input are in volts, and it assumes that the output is a 1 ohm load, like a unit load. So this scale in power is obviously not accurate, but you kind of get an idea for how it works. And I plan to make the frequency domain chart much more advanced in later versions of this program. And that's useful, like if you're like with a balancing robot, you'd want to maybe look at the Fourier transform of the pitch, and that way you could see if it's oscillating at a certain frequency, stuff like that. One of the things that I changed is for pretty much everything except for the dial, everything can chart multiple things. So if we go back to that Fourier transform in a frequency domain, to get a frequency domain chart, if I do all three, it can overlay them. So you can kind of, if you have similar signals and you want to get a visual comparison, that'll be quite helpful. And same for the histogram. So if we do a histogram, you can check multiple values and they'll all be overlaid. And so if I move the robot, you can kind of see that. So that can be kind of helpful. The time domain chart and the time domain chart cached didn't change very much. I kind of went over those. Oh, so the histogram, one thing I forgot to mention. So I wanted it to show both the relative frequency, which is here on the left, that's like a percentage, and then the frequency, which is like the count, the size of each bin. So that's one thing I added, so that way I could see both at the same time. If you have an unusual sample length, like if you make the duration of that chart like 1234 instead of like a nice clean number, you'll see that these will be independently drawn, and in fact I can kind of show that. So you can kind of see that the two axes, or the divisions on the left and the right are independent, and I did that on purpose. I wanted it to be kind of clean divisions. So here there are 0.01 per division, and here is 10 per division. So it'll look kind of weird, but it's intentional, and I find it helpful because I often want to look at both the count and the relative frequency. And then for the dial chart, it replaced the statistics chart, and it kind of shows similar information. So the dial that's moving rapidly right now is going to show the current reading, and it's scaled for the minimum is down here, the maximum is over here. We have the mean over here in the corner, and the standard deviation in the top right corner. So it kind of shows similar information. I didn't really break it apart into percentiles. I might add that back in later. Anyway, let's get into the tutorial, basically, where I show you how to write the Arduino sketch, and then I'll in more detail show you how to use the program, step by step, how to go from configuring it to talk to the Arduino, creating all of your charts, saving a layout, opening a layout, and so on. Oh, and there was one more feature that I forgot to bring up earlier. We are able to log all data to a CSV file that you can open up in a spreadsheet program like Excel or OpenOffice, but I'll get to that later. So yeah, let's cover how to write the Arduino sketch. So go ahead and open up Arduino, and you're going to want to go ahead and open up the analog read serial template, which is already open. But if you go to File, Examples, Basics, Analog read serial, it'll come up if you don't have that already. Okay, I'll go ahead and write the code, and then I'll explain it afterwards. Alright, so there's the code. As you can see, it's very short. For now, you can ignore this part. But basically what you need to do is you need to set up the serial port at some baud rate. The default of 9600 should be fine. In your loop, you're going to want to get your sensor readings or whatever it is you want to visualize as integers. Well, actually, you could use floats or doubles if you want, but generally on an Arduino you wouldn't need to. Anyway, so you get your three numbers. Create a character array called text, and just make it bigger. Well, you'll see in a second. Yeah, sorry. Okay, I'll get back to that. And then, so what you need to do is use sprintf, and it will copy into that text variable the three sensor values, and this format string tells it how to do that. So %d means print the number as a decimal, which is base 10, what you would expect. And so print a number as decimal, print a comma, another number is decimal, print a comma, and another number is decimal. And then you tell it the three numbers, so sensor 1, sensor 2, sensor 3. And then you do serial.println, and you just give it the that variable. And the reason why I had to do this is I'm actually powering my thermistor from the A2 and A4 pins because I didn't have enough power pins, and it was just a convenient way to do it. So basically I'm using pin A2 as an output, and I'm driving it high, so that's basically my 5-volt pin. And I'm using A4 as an output, and I'm driving it low, so it's my ground pin for the thermistor. You probably won't need to do that, but that's why that code is there. But generally you can ignore that code. Yeah. And so if we verify the code, so that's good, done compiling, no errors, and if you upload it, and good, done uploading, no errors. So if you go to the serial monitor, it'll connect, and then we have our values. And let me kind of explain what we're looking at. So sensor 1 over here, which is I've set it to pin A0, is going to be printed out in this first column, the 469, and that happens to be the potentiometer. So I'm going to go ahead and turn the potentiometer right now, and you can see it changing. So that first column is my potentiometer, and it varies from 0 to 1023, and that would be sensor 1 here. The second column is sensor 2, and it's the one here, 392, 394, and I have that connected or wired up to my light sensor, the cadmium sulfide cell. And so if I move my finger over it, you'll see that number change, and if I take my finger away, it'll change back. And then finally, yeah, sensor 3 is the third number, and I have it connected to pin A3, and that is my thermistor. So if I put my finger on it to heat it up, you'll see that number slowly change, and if I take my finger off, it will slowly change back down. Alright, so that's basically all you need your Arduino to do. You need it to send, it's called a comma separated value, or CSV, well, values, multiple ones, and that's what we're doing here. So earlier I was talking about how you need this to be 40 characters. It doesn't need to be 40, it needs to be bigger than whatever you're going to print here. So in this case, the maximum number will be 1023 for any of these numbers, and that would be 4 characters. So there could be 4 characters in the first column, second column, and third column. That's 12 characters. And then 2 commas, that brings it up to 14 characters. And so I only needed really 14, or actually 15, because you need that last number to be a null character. But if you make it 40, it's plenty big enough to where you're not going to run out of space. But that's why I put 40. Not a big deal. Anyway, and so if you have more sensor values, you put more here. So you could do another comma, %d, and then you could put sensor 4 there, and then you would have a 4th column over here. But yeah, really simple, really easy to do, very straightforward. So now let me go ahead and go back to my program, and I'll show you how to connect to the Arduino and how to use the program. Oh, one thing before you close your Arduino software, take note of what COM port your Arduino is at. So mine happens to be at COM 3, yours could be different, so just keep that in mind. So there will be a link in the video description to the code and well, the jar file, which is the program, and then the source code for it. So if you download the jar file and you double click on it, the program will come up. And you will need Java installed, so if you do not have Java, just go to Google, type in download Java, and then download it. Be through Oracle is the provider of Java. But you probably already have it installed if you're doing Arduino stuff. Anyway, so here's the program, and the first things we need to do is down here in the bottom right corner. The sample rate is how often we're getting those samples from the Arduino. And if you recall, the last line of the code was to have the Arduino wait 10 milliseconds. And so basically that means I'm sending 100 samples per second, because 100 times 10 is 1,000, and there's 1,000 milliseconds per second. So I'm going to go ahead and type in 100 there for the sample rate. This value is not critical, but I'll explain why it's helpful in just a few minutes. Leave this first one as ASCII CSVs. There's an option for binary. It doesn't really work correctly yet. I wanted to have a higher efficiency mode where you could do binary packets. I have it kind of working, but it isn't really polished, and it'll be really confusing, so don't try it yet. Always leave it at ASCII CSVs, and then choose the COM port, which would be COM3, and then the baud rate, which we left at 9600, but make sure it matches whatever you wrote in your Arduino code. And so you click Connect, and then we have a data structure window, and this will let you tell the software what those columns mean. And so column number 0 is the first column, and you give it a name. And so in my case, that first column that we saw in the Arduino serial monitor was my potentiometer. So you can give it a name. I'll type it in as potentiometer. You can set a color, which is what the line color will be, or the bars in the histogram, or the color of the dial. So if you click that, you can pick a color here. Normally this will be bigger, but I'm using display scaling because I'm actually on a 4K monitor, and for some reason this Java color picker doesn't scale. But anyway, it should be a little bit easier to see for you. And there's also other ways to enter numbers, or to enter colors. I'm going to leave it as the default red, so I'll cancel. And then for unit, I'm going to go ahead and scale these numbers into volts. So we'll have to make the unit volts. And then the Arduino has a 10-bit ADC, which will give you a number from 0 to 1023. So it's a maximum of 1023. And I have a 5-volt Arduino, so it'll be 5 volts. Basically, we're telling it scale the numbers so that 1023 is equal to 5 volts. LSBs means least significant bits. That's just kind of a technical term for like the raw number, the count. And then you click Add. And now we can define column 1, which is the second column. And for that, I have my light sensor. And we'll go ahead and pick a different color. Let's go with green. I'm not going to calibrate it, so I'm going to leave the unit blank. And I'm going to go ahead and erase these scaling factors. And click Add. And then the third column, which is column number 2, was my thermistor. And we'll change that color. We'll make it blue. And same thing, I'm not going to give it a unit. I'm not going to scale it. Just click Add. So we can kind of see here, this is what the software knows. So the first column, column 0, is the potentiometer. It'll be drawn as red. It'll be scaled to volts. And the conversion ratio is an input of 1023 will be mapped to an output of 5 volts. And it's just a simple linear scaling factor. And then we have the other 2 rows. And you keep on adding rows if you have more values. If you made a mistake, you can click Reset, and that will delete all the rows down here, and you can start back at column number 0. When you're done, click Done. And now you're ready to make all of your charts. So if you click and then drag, so click and drag and let go, you can add a chart. So the first option here is the chart type, and there are 5 types. You have time domain chart cached, frequency domain, histogram, and dial. So I'll go through all of them. We'll start with the time domain chart. Duration is basically your domain. How many samples do you want to see on screen? The default is 1,000, which in our case, because our Arduino is sending about 100 per second, means we'll get a graph of about 10 seconds. And let's take a look at the potentiometer. And then click Add Chart. And there are the values. So it has scaled the potentiometer reading into a voltage. And you can kind of see that over here on the left. And the potentiometer is just sitting there, so it's kind of bouncing between 2 different values with a little bit of noise. If I move the potentiometer, you can kind of see it'll go all the way from 0 up to about 5. And my potentiometer has detents, which is why that looks kind of notchy, but if you have a regular potentiometer, it would, smoothly reflect the rotation. And so we can add another chart. You just click and drag like before. And the next chart would be time domain chart cached. And it's very similar. I'll go ahead and leave the duration back at 1,000, and same as potentiometer. You can see that it looks basically identical. The most obvious difference is when it auto-scales. It's not as obvious yet. Let's wait for it to... when it auto-scales and it gets rid of this stuff, you'll see that the chart here on the left, it'll very smoothly auto-scale back down, and this one is going to kind of a little more choppy. Yeah, like that. Okay, so the reason why is the cached version, instead of redrawing the chart every single frame, it actually records little strips, and they're kind of moving across the screen. It's caching the actual pixels. And if you're doing something simple with an Arduino, you don't need to use the cached version. But if you're going to chart a large number or a very large data set, like 100,000 points, 500,000 points, 1,000,000 points, it'll really struggle to do it real time if you don't use the cached version, because that'll be a whole lot of lines to draw, live at 60 frames per second at whatever your resolution is. So the cached will help if you're using very large data sets. If you're not, then you don't need to use it. Don't worry about it. Let's make another chart. So click and drag. You can do a frequency domain chart. And let's look at the light sensor, because that'll have a little more, movement to it. So you can kind of see there's a few peaks here. There's one around 30, 37. There's some things there. I'm not sure, that might be from a. In fact, I don't know. There's an LED, a little status LED from my computer that the light sensor is aimed at. I wonder if maybe there's some PWM harmonics that are, for some reason, all the way down at that low of a frequency. Anyway, yeah, so you can kind of get a feel for the frequency content of a signal. If you don't know what that means, don't worry about it. It's just when you get into more advanced signal processing, you often want to look at frequencies instead of just time. But let's look at another graph. The histogram chart, which you guys saw earlier, we can do that as well. And it will show you, a probability distribution. So right now the thermistor isn't changing at all, so it's constantly at 532, and that would be 1 for relative frequency, 100%, and 1,000 counts. If I touch the thermistor, you'll see that kind of changes, and if I let go, it will get cold again. So yeah, this is kind of a neat way to look at the distribution of values, just a nice kind of statistical tool. And I think we kind of covered most of how that works earlier. Let's go ahead and remove a few of these charts. So, yeah, so if you move your mouse over the chart, you'll see this X in the top right corner. And if you click on that, it will close the chart for you. So we'll go ahead and add another chart, and we can do a dial chart. And that will only be able to show one value at a time, so you could show the light sensor. And it's going to auto-scale, so when we set that duration of 1,000, it'll be, well, here, let me show you a line graph. So you can, yeah. There we go. So you can kind of see it's jumping around here on the dial because the auto-scaling is only between 395 and 389, so there's not much going on there. If I move my hand in front of it, now you can see we have a much bigger range, and so the dial is going to look a little more normal. So the dial is going to show the current value. The minimum value is down here on the left, maximum is over on the right, mean is up at the top left, and standard deviation at the top right. And so let me go. If you click the reset button down here, you can it will erase every chart, so it's like clicking the X for everything. And I'm going to go ahead and add in a bunch of line graphs. So I made these 3 rows high, but there's only 2 down here. Well, we can resize the grid. So you have the number of columns and then the number of rows. So if I want to make 9 rows, I can put a 9 there, and there you go. So now we have room here. You can show the thermistor. And then, well, okay, I want to add more charts over here on the left, so I can add more columns. We can make that, say, 12. And we could do, our histograms, which would be kind of neat. And so you can see it's very easy and quick to add charts. I wanted it to be very straightforward, kind of a not like a hardcore engineering tool where you have to enter in a whole bunch of stuff. I wanted it to be kind of a quick just data visualization tool. And so if I move my hand in front of the light sensor, and if I rotate the potentiometer, let's get these charts to look a little interesting. If I touch the thermistor, there we go. Okay, so, and then like I mentioned at the very beginning of the video, if you rotate your scroll wheel, you can rewind in time. So I can rewind time, and everything will update. The line charts, the histograms, everything would update. And then you could zoom in. So if you hold down Control and then move your scroll wheel, it will zoom in. And like I mentioned earlier, it will scale about the end of the chart. So that's why, like, this part is stationary and these are kind of flowing away from you. And you can zoom in as far as you want and see the individual samples. So you can zoom back out. And then, again, like I mentioned earlier, if you hold down Shift, you can do the display scaling where it will make everything really big. So you can read it from literally across the room if you want to. That's pretty much the majority of what you need to know to use the program. If, for example, you want to save your layout, like if you want to open this up again later on, without having to enter in the data structure and then click and drag to create all the charts, you can go down here, click Save Layout. I'll go ahead and put it on the desktop, and I'm going to call it Test 1, 2, 3, 4. Press Enter, and if we close the program, we now have that file here. And if I open the program again, you can go to Open Layout and find the file, and it will open the layout. So there we are. Let's see, I already covered reset. If you click on help, it just tells you kind of what I've been telling you over the video. So it tells you to use the controls at the lower right to connect, and then you define your data structure, you click and drag, and then how the scroll wheel works. So yeah, that's the majority of, or that's pretty much all of it. I wanted to keep it very simple and easy to use. Oh, one thing I forgot to mention, the sample rate. In theory, it isn't important, you could leave it out, but it does two things for you. One, if you do the frequency domain chart, it does need to be accurate if you want your frequency scale to be accurate. And then even if you don't care about that chart, when you scroll, like if you rewind and fast forward in time, it will try to make one click of your scroll wheel to be 1/10 of a second. So in this case, one click of the scroll wheel would be about 10 samples. You can kind of see that. And so if you have this number way off, then when you scroll, it might look kind of weird. But that's it. It's not really a critical thing. Those are the only two times that number comes into play. So if you close the program, you'll notice that there will be a file called log.csv. It'll be in the same folder as the program. So it happens to be on my desktop, so it'll be on my desktop. And that is just a log of all the readings. So you can do more professional analysis if you have a need to. So if you open up the CSV file, I have OpenOffice installed, and then it's a comma separated values, so make sure it's only going to separate based on a comma. You don't want it to separate based on spaces or anything like that, just comma. And then there's your values. So we have our potentiometer readings in this column, the light sensor readings, and the thermistor readings. And then we have a timestamp over here on the left. If you are sending data very fast, keep in mind that this will not be a perfect timestamp. Windows is not a real-time operating system, so it will not be as consistent with things that are very fast. So even if your Arduino is actually sending data once per millisecond, you may get timestamps that kind of jitter around, a couple milliseconds or whatever. The operating system will buffer the data on the serial port, so that's why you get that. There's really no way around that. And then finally, you notice that in here the potentiometer reading is it is not scaled into volts, and that's intentional. These are all the raw values from the Arduino or whatever is talking to the software, whatever microcontroller you use. I didn't want it to store the scaled values because then you have floating point error that is potentially adding up. I mean, it would be a small amount of floating point error, but it'd be imperfections that it might be easier to look at the raw values. Anyway, so this is your log of data, and so you could maybe make a chart if you wanted to. So you could pick the light sensor. I don't really do much with spreadsheets, but I think it would be, yeah, insert and then chart. And you could pick your chart type, I guess. Probably a line chart would make sense. And we can go there. And yeah, so that's kind of a weird looking x-axis, but yeah, that's the data. Anyway, I'm sure Excel would look better. Or maybe people that know better than me with spreadsheets could figure it out. But anyway, there's all your raw data, and it can be a useful tool. I hope you guys found the program helpful. There are links to the program and the source code in the video description. And now I'll go ahead and go through the source code so that you guys can get a feel for how the code is laid out. If you feel like playing around with the code and maybe modifying it, making it do whatever you want. All right, so here we have the source code open. It's a folder called Telemetry Viewer, and it's written in Java. And of course, I'm using OpenGL for the data visualization part. And I'll kind of walk through how all the code is laid out. So it all starts in main, of course, and that would be in main.java. And there's not really a whole lot going on in this particular file. I start off by telling it to use the look and feel of the operating system, which would be like Windows, to make it look like a Windows program. And then I create a JFrame and I give it a title, the OpenGL charts region. Let me go ahead and bring the program up. The charts region is this grid area where all the charts would be, and the controls region is the bar at the bottom with all of the controls. And then I lay out the window and I set it to be maximized and I show it, and that's really all there is in main. All the work is elsewhere. So if we look at the controls region, this is that bar at the bottom with all the buttons, and so we have all of our buttons, and it registers event handlers to do all the work. So you can kind of poke through there if you want to modify that or figure out what happens when you click on a button. And then the charts region, go here. And this draws that grid and then all of the charts. So, and it also handles all of the mouse events when you're over the charts. So it keeps track of the grid and where you've clicked and dragged to create the chart. And the GL canvas object is where we're actually drawing that grid and all the charts. For a GL canvas, you have to add a GL event listener event handler. And that interface has an init, an init, a init method, and that will be called at the beginning to initialize your OpenGL code. So I turn on blending, which is like anti-aliasing, and I enable it for lines and points. I used to have it enabled for polygons, but I find that on NVIDIA drivers, if you draw a quad, it will actually anti-alias the two like implicit triangles of the quad separately. So it gets you have this really weird transparent diagonal in your quad. Looks kind of funny, but anyway, that's why I commented that out. The reshape event handler, I guess you could call it, it just changes the projection matrix and keeps a log of the current width and height. And the real work is done in the display method. And basically draw the background, draw the grid background, draw the vertical lines, the horizontal lines, the bounding box for wherever you click and drag when you're trying to create a new chart, and then all the charts. And yeah, there's a whole lot going on here. The animator is what tells the GL canvas to repaint every frame. So in my case, 60 times a second. And then I have a mouse listener to keep track of, when the user clicks and releases and all that. Mouse motion listener, same thing. Wheel listener, more of that. And then I tell the controller that I want to be notified if the grid changes. And that's about it for that. So you could then look at the charts if you want. All of the charts start with OpenGL, so you have the dial chart, frequency domain chart, histogram chart, time domain cached. Let's take a look at the regular time domain chart. So every chart has a get descriptor method, static method, and it is used by the code to figure out the how do I phrase that? Okay, if I let me load up that Arduino demo real quick. So I'm going to go ahead and delete a chart. If you were to create a chart here or anywhere, this window, it needs to know, what options are available for each chart. So like the dial chart can only take one option, but the time domain chart, you can have as many as you want. And so that's what the descriptor does. It tells it the default duration, the minimum and maximum, the inputs, and then if the user clicks the add chart button, it can create that chart object. When we create the object, we're basically calling the constructor of the parent class, which is a positioned chart. I'll get into that in a second. And then we create an object for auto-scaling the y-axis. And I'll get into that more as well. And so, yeah, one thing is I have JavaDoc written for most of the code, not all of it, most of it. So if you move your mouse over a method, it'll tell you. It'll tell you what it does and why. Anyway, and so then the bulk of the work is done in the draw chart method of any chart. And so it will draw a background color, and then it'll draw a rectangle around the perimeter. And then it will calculate, or it'll get the samples and calculate, all of your domain and range values. It'll auto-scale them accordingly. And then it will calculate the positions of every little part. It'll get the divisions. And then it will draw a gray background in the plot area, and then it'll draw the vertical division lines and horizontal division lines, and so on. And so kind of you get the feel here. I don't want to bore you guys. I'm not going to really walk through every single part of every chart, but that's kind of how it works for all the charts. A similar kind of process for all of them. The cache chart, like I mentioned earlier, it uses cached data. Like it'll actually cache the pixels. It'll keep a 32. It'll render the entire chart as a bunch of 32 pixel wide strips or slices, and that is what this object is, the OpenGL time domain slice. And basically it will create a frame buffer and a texture, and then it will render into that texture so you can cache the data. It will keep the data as a samples GL object, or an array of them, because you could have multiple things being charted in one chart. Like you could chart like Gyro X, Gyro Y, and Gyro Z all in the same chart. And so when you create the object, it will create the frame buffer and the texture. And if you call update samples, it will get new samples from the database basically. And it will calculate the min and max. And then if you call update slice texture, it will determine if it needs to redraw the texture, and if it does, it will. So there's a whole lot of logic in there, and then we update that frame buffer. And then there's render slice at, which will draw that texture at a particular location on the screen. And so yeah, that's about it for that. Let's see. AutoScale is what handles auto-scaling an axis, and there's kind of two modes for that. The exponential mode is what you mostly saw, where it will smoothly transition to a larger or smaller scale as needed. The sticky mode is used in the cached time domain chart, and it basically will only auto-scale if it has to. So if you push too far, if you go too high and you'd be off the screen, it will rescale because it has to. And if you get really far away from the edge and you're wasting a lot of space, then it will rescale, but it will not constantly rescale. And that's because with the cache, ideally you don't want to be flushing that cache every frame. And so there's just the logic in here for all that. The binary processor is for the binary packet mode, which isn't really polished yet, so I'm not going to go into too much detail there. Chart utilities. This is used for determining the size of the X and Y divisions. So it will try to give you a nice clean number instead of you know, just randomly splitting it up. So you can get, there's a version that'll give you Y divisions as a floating point number, Y divisions as a log. So basically that's only used for the frequency domain chart because the power is shown as a log axis. Otherwise it would look, well, yeah, it would look weird. It would be, you wouldn't see any detail. And then you can get the X divisions either as integers or as floating point numbers. And that's a little helper function to get a number formatted as a string using a specific number of characters if possible. That's used in the dial chart. For example, the minimum and maximum values. Oh, here, let me show you. So if I put a dial chart here, so I wanted the minimum and maximum numbers over here on the two corners to show, you know, basically 6 digits of resolution, and that's what that function does. Like it will try to show up to 6 values, but it will, if there's a decimal point and there's way more than 6, it will cut off that, but it won't cut off integers. So yeah. I have the code set up as a ModelViewController, and so the controller is what handles the it like mediates access to the data, which is the model. And so it's a big long class, and it handles pretty much all of that. Yeah, it'd be boring if I kind of went through everything, but you can kind of scroll through. There's methods related to the data sets and the serial ports, or serial port, and everything else in there. Let's see, dataset. A dataset is an object that stores all of the data for like one of those CSV columns. And so it needs to know the location, which would be like, is it column 0, column 1, column 2? We're not doing binary packet mode yet, so you can ignore that. The name would be like, potentiometer or thermistor or whatever you want. And then the color and the unit, conversion factor. And you can get samples, you can insert samples, all that is handled here. So yeah, I'll try to make this quick. I know it's been kind of drawn out. The model is basically where all the data is stored. And there's some of the limits too. So the grid has a default of 8 columns, but it has a minimum of 1 and a maximum of 20. You can change those if you want, and so on. And so there's default values here, and this is where all the data sets are stored. All the charts are, we keep a list of them in here. The new chart window is the window that pops up when you try to make a new chart. So this is the new chart window. That's all here. Pretty straightforward. I'll try to get through this a little bit quicker. I know you guys are probably really bored. Position chart is the parent class for all the charts. So it has values that every chart would need to have. The chart needs to know its position, so the X and Y coordinate of its top left and bottom right. It needs to know its duration, which is how many samples it should show, and it needs to know what it's going to show. And so when you create the object, it'll log all that. There's a helper function where if you give it a coordinate in the grid, it can tell you if that chart is overlapping with that area. And then Reconnect datasets will let, if you disconnect from a port and then reconnect, it's possible that if you change the data structure a little bit, that the datasets would change their location in memory. So this reconnects them. Kind of confusing, but you don't really need to worry about it. Samples and samples GL. So I kind of go over all that right here, but basically when you need to get data from a data set, you can get an individual sample, you can get a float array, you can get an object, which would be this class, the samples object, which will have the float array, and it will also tell you the minimum and the maximum, the color, name, and unit. And then there's the GL dataset version, which is this object, and it will give you basically the same information, but instead of being a float array, it's a float buffer, and it's formatted in a way that you can basically give directly to OpenGL, and it's more efficient if you're going to draw a line graph. It just stores the x and y coordinates, and you treat it as a vertex array. And then I have a lot of the theme details in the theme class, so you can change colors and stuff like that, the default lengths of various parts, default fonts. And then font utils kind of handles the rest of the theme as far as relating specifically to fonts. And it's also used by all the chart classes to draw text on screen. So it will queue up data for each chart, and then you can, at the end of the chart, after you draw the chart, you can empty that queue and draw the text. And so each chart would call these draw functions, and that would put stuff in the queue. And then the OpenGL charts region will automatically call the draw queued text for you, and it will empty the queue and draw the text for you. That's pretty much all the code. As you can see, there's comments everywhere, so feel free to look around. Feel free to ask questions. I don't want to go into too much more detail because I'm sure you guys are already bored and it's been a long video. So sorry about that. Anyway, that's the program. There is links to the program and the source code in the video description. If you guys have any questions or comments, please leave them down below. And if you know anybody that might benefit from the video or the software, please share a link to this video. I'd appreciate it. All right, have fun.